Okay, so initially the stream will be private. I by mistake had it public, but now I made it private. So till the contest ends, it will be private, and after the contest, if the contest goes well, I will make it public. Okay. So let me change the name of the stream. Yeah. Okay, so we have 45 seconds remaining, and I will use Sublime Text for solving the problems, and I might code in C++ or Python both. Okay. So I use both the languages, and whichever I prefer, I will use it. Okay. And I will use OpenBoard for doing my rough work. So you will be able to see what I do in the rough work to solve the problem. Okay. Yeah. So we have 14 seconds remaining. What is the time in the stream right now? Okay, so first problem, man of the match. In a cricket match, there are two teams, each comprising of 11 players, obviously. The scorecard of the match lists the runs scored and the wicket taken by each of these 22 players. Okay. Determine the man of the match. We access the man's performance by the points awarded. For each run, they earn 1 point, and for each wicket, they earn 20 points. Yeah. And the player with the highest total points award the man of the match. Okay. You are given the scorecard of the cricket match. Listening contribution of the listing the contribution of all the 22 players. The players are numbered from 1 to 22. Find the man of the match, obviously. Okay. So what are we given? Like input format, we have t test cases, and then we are given 22 lines for every test case. Okay, so I think I will do it in C++. So we have for every test case, I will run the solve function. Uh, so we have an answer, and endpoints is equals to 0 for in range 1 to 22. Obviously, now for every point, what are we given? AI and BI, the runs scored and the wickets taken. Okay. So I will say int a comma b, say in a and b, int points is equals to a plus 20 times b. If points is greater than pt, then I will say pt equal to points and answer is equals to y. And in the end, I will simply print my answer variable. So let's run this. Actually, let me copy this. Okay. And this is the expected output. So let's run this again. So which is correct. Let's try to submit this. I hope it was recorded. I'm not sure. Yeah, it was recorded. Okay, now, yeah, we got a correct answer. Let's move on to the next problem, that is Arya in the grid. So Arya the monkey is trapped inside an n cross m grid. The graph has n rows numbered 1 to n from top to bottom, and m columns numbered from 1 to m from left to right. Okay, so we have one based indexing. The cells at the intersection of the, okay, Arya wants to escape the grid, of course, but first he needs information. Arya initially is at cell x naught y naught of the grid. He can move to the other cell by jumping to them, obviously. Now Arya jump strength length is L, meaning that Arya can jump exactly L units in any of the four directions, left, right, down, up. Formally, yeah. Okay, provided a destination is within the cell, how many distinct cell in the grid can Arya reach having 0 or more jumps in this form? Okay. Okay, so we have n and m till 10 to the power 9. So we want to solve this problem in big O of one time, basically. Let's just copy the sample input first and the expected output that we need. Okay, let's read the input format. First we have a test case, then for every test case we have 5 integers n, m, x naught, y naught. So we have n, m, x naught, y naught and l. Cn, n, m, x naught, y naught and l. Okay, so now if we see, like, if we are given an n cross m grid, so let's say we have some n cross m grid, or let's just try to generalize it, like, okay, if we have some 3 cross 3 grid, and if I am here, if my jump strength is 1, then I can go to all n square numbers, like n into m numbers, like all 9 squares. If my jump strength is 2, from here I can go, I can cover this square and I can cover this square, and okay, and from here I can cover that square, obviously I can cover this square also. So I will be only able to cover these 4 squares and none other for l equals to 2. Yeah. If I was at between, then I will be only able to cover this square, so that's it. So I think it is pretty simple. Like, if you are at x naught, what I can do is no, that is not. Like, if I have n, then what is the so if I have like 1 to n, okay, and if I am at x naught and I can only move to x plus l or x minus l, so what I should do is, let's go to the first position. Okay, so if I have x minus some multiple of l, um, which is greater than 1, so this will become x minus 1 upon l, right? Yeah, I think this will work. Like, let's get the first smallest smallest x that I can get, then the largest x that I can get, and then similarly do it in y direction. That will be because for 3 cross 3 I can get 1, 2, I can go till n. I think this is, if I am at x naught and I keep subtracting x naught minus k into l equals 1, yeah, just greater than or equals to 1. So x minus 1 is greater than equals to kl. So k is x minus 1 upon l, right? So what I can get is, from here my start will be equals to int a is equals to x minus 1 upon l, right? Or actually it should be x naught minus 1 upon l, and int b is equals to, similarly it will be equals to y naught minus 1 upon l. Okay, so that is my product, and now I have to subtract this from x naught. So x naught minus equals to what, this number a times l, so I will subtract it, and y naught minus equals to b times l. So this is the maximum upward cell that I can get to. What is the maximum that I can get to from here? Like, if I am at some position, I want to go till n, but x plus k l less than equals to n, so it will become equals to n minus x upon l. K has to be less than equals to n minus x upon l, and in this case, so in this case I have to take ceil, in this case I have to take that I think I get it now. So let's actually do this in Python, because we have a nice ceil function here. So cp template and from math import ceil. Okay, so first we have n, m, l. I forgot what was the input format. N, m, x naught, y naught, y naught, l is equals to map int input dot split. Okay, now I want to get like int a is equals to, it will be equal to, first of all I need x minus 1 upon L ceil of this number plus n minus x upon L, the floor of this number, and similarly I will need, let's just duplicate it. So not sorry, I forgot the syntax. I messed up the syntax. Int b equal to y minus 1 upon L and y m minus y upon L and print a plus b. I think a into b. Sorry. So this is giving me x is not defined. Let's name this x and y. Okay, we are getting wrong answers obviously. And why are we getting wrong answers? Because yeah, for this we are getting a 0. Let's see, we are at 1 1 1 1 1. For this we are getting correct answer. For this we are getting, like if we are at 1 1 1 1 1, we are at 1 comma 1. So my answer should be a comma, I am at the correct index. So I have to get answer as a to be minus 1. Max of this. Okay. I mean, this is correct. Like if I have 3 cross 4, let's try to do it for 1 cross 1. So if I am at 1 cross 1 only, okay. I mean, this was a special case, so let's actually leave it. Like if everything is 1, then obviously the answer will be 1. But let's say 3 4 2 3. So we have 3 1 2 3. 1 3 4, and so we have 3 cross 4 matrix, and then we have 2 comma 3. So we are here, and the step size was, I think, and the step size is 2. So from here I can reach 1 2, I can't go there, 1 2 I can't go, so I can only reach here. So there are only 2 cells that I can visit. Okay, yeah, so I have 2, and in this direction I think I have only 1. So let's actually print my a comma b. So for this case it was 0 and 0. Why is this 0? Because n is 1 and x is also 1. Yeah, I think that is why we are getting a 0, but in this case we are getting 1 and 1. This is wrong. Why is this wrong? Because x minus 1, this difference, if it is, if the difference is, I mean, obviously I have this possibility and I can get here, but if the difference is equal, then I should not take the seal. Okay, let's actually make some cases. Let's say if I will say n minus 1, not n, x minus 1 mod L equals 0. Okay, so if the step size is 0, then a is equals to x minus 1 upon L plus 1, else a is equals to x minus 1 upon L. And now similarly, if y minus 1 mod L, maybe I think I should repeat this step. So this should go here, and similarly I can say n minus x model equals 0. Then this is not this is nothing complex, but why am I complicating it? I don't know. Let's say I am at 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8, we have 9, right? So we want to traverse from 1 to 9, and let's say we are at 5, and my step size is 2, so I can go from I can simply divide 5 by 2. So 5 by 2 is how much? 2 2s are right, so I can go from 1 2. Yeah, but what if it was 3? 5 by 3 is 1. What if it was 1 1 2 3 4? What if the step size was 5 only? So 5 upon 5 is equals to 1. I can go one step here. Yeah, 1 2 3 4 5. I can't go actually beyond go beyond 5. So let's see. Like from here, how many steps can I take in this whole line? If I have only if I have L equals to, let's say, 1, so I can go to every steps like 1 2 3 4 5 6 7 8 9. I can go to every step. Yeah. Let's say I have L equals to 2. Then from here I can go 1 2. I can cover this. I can cover this. What is happening now? I think some glitch occurred in my open board. Let's actually use something else. I think I will use OneNote now. Oh, the internet is poor right now. Is the stream visible? I think I will waste a lot of time in this problem. Let's see how it goes. Yeah. Okay. Okay, so let's say we have a number line and we are at 1, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. If I am starting from why is this happening? So if I am starting from 1 and my L was equals to, let's say, 2, so I can cover 1 3 5 7 9, right? So how many numbers are these? So clearly these are 10 upon 2, which is equals to 5, right? 1 2 3 4 5. I can cover 5 numbers easily. Now but what if I am starting at 2? So I will be able to cover 2 4 6 8. This is messy now. If I'm here, then I can go for this. Should I write a brute force? I don't want to waste much of my time on this problem. And 400 people have actually solved this already. What I want to do is, first of all, I want to get the minimum that I can get from this from somewhere. Like if I'm at n equals to 1, then till L, if I keep doing it, so what is the minimum that I can get? I want to get that number. So basically, if I have, let's say my uh, start x is equals to 1 x, while sx greater than 1, uh, greater than L, sx minus equals to L, fx equals to x. I can say while fx less than n minus L, fx plus equals to L, and now the number of terms will be equals to like what is the nth term? Nth term is simply, I don't know why this is happening to me today. So many glitches are occurring. A plus n minus 1 d is equals to r, right? An. So I can simply subtract an minus a upon d plus 1. So these are the number of terms that I will get. So now I can say a is equals to fx minus sx upon L plus 1. Similar thing I can do for y also. So let's say sy equals to y, and similarly I will say while sy is greater than L, sy minus equals to L, sy equals to y, m minus L, yeah, this is b, and print a times b. So if I do this, I think this will give me what is happening. Even this is wrong. Why? Because actually let's say that we only have 3 test cases for now. What are the values of my a and b? My a and b is 190,6 for this case, which is wrong. There must be a simple logic for the problem, uh, which I can't guess right now. How much time do we have? Okay, I wasted 10 minutes on this problem already. Okay. Okay, so it says we are at 1. We have a long number line. We can have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Let's say 11 because it is a prime number. If I'm starting from a number like 3, let's say I am at any number, let's say we are at 5. How many numbers can I go before this? Like what is the start index that I can get? If I am starting from 1, so 1 plus some numbers, or maybe if it is an arithmetic progression, then I want to say like 5 minus uh, so n minus 1. So this is equals to actually, like if I am taking steps of 3, so 1, 2, 3, so I will be able to visit only 2, right? So I can say 5 minus, why is this happening? Why is eraser getting selected automatically? Okay, so we have 5 minus 1 is 4, 5 minus 1 is 4, 4 upon 2 is, no, I can't take 4 upon 2, 4 upon 2 is equals to 2, and 2 is equals to n minus 1, which is wrong. Like 5 minus 1 is 4, and it is exactly divisible by 3, 1, 2, 3. Okay, 4 upon 3 is 1, 4 upon 3 is 1, So I will get one term from here. So can I get my start term from this? Like if I know my I got this as the answer. Let's say L is equals to x minus 1 upon L print L. X minus L times N. What is that? Like first term is 2. First term is 1, yeah. And the second term is if we are at 3 comma 4 and I am at 2, then I can't actually subtract this. Okay, so this is my start x, right? And now I can say my finish x will be equals to, let's say n2 is equals to n minus x upon L, and my finish x is equals to this number. Like if I want to have x plus n2 into L. Okay, so we have this now. Why are we getting, what was my fx and what was my sx? Okay, so sx is minus 4. This is because we should have taken n1 here. Okay, so we are getting 1 and 1. So obviously this will be equals to 1, and in here, okay. So we had first we have 1, then now for this test case we are getting 2 and 2. So my start element was 2 and second and the end element is also 2. So I can label this variable as a. Okay, and let's do the same thing for y coordinate. So let's say n2 is equals to y minus 1 upon L. Sy is equals to x minus 1 upon, let's take this n3. So this will become n3 and this will become y minus L times n3. Yeah. Let's say n4 is equals to m minus y upon L, and fy is equals to x y plus n4 times L. So b will be equals to fy minus sy upon L plus 1, print a comma b, and what happened? Print a times b. Okay, so if we have this, we are getting 6840, which is correct. Yeah, this much is correct. Let's make this 4. Yeah, this is giving correct answer. Let's actually submit this in Python 3. Yeah. Okay, we got a correct answer. Let's move on to the next problem. I think I was actually late when the contest started, so I'm pretty slow today, and my rating will surely fall now. But doesn't matter. We are going to the next problem, that is transformation cost. Okay. Ayush being interviewed for an executive role in the finance department of Aparoksha IIT Allahabad annual fest. Okay. Himanshu Shekhar, the interviewer, decided to test Ayush's mathematical skills with the following problem. An integer is called good if when written in binary. It doesn't contains 101 as a subsequence. What? Okay. For example, 4 and 15 are good because they don't actually contain that. Now, while 9 is not good because it contains 101. Now that the subsequence need not be continuous, Ayush is given and he can do the following operation: choose an integer x and add 2 to the power x to n. The cost of this operation is 2 to the power x. Find the minimum total cost needed to transform n into a good integer. You can help him find the minimum cost. Okay, so let's first actually analyze this. Like, when will an integer never be good? I don't like this one note. Can I use my open board again? No, there is some error with it. I don't know what exactly happened. Maybe I will try good notes. If you know some good text good writing setup, then can if you have some good writing setup, you can recommend me in the comments. I will really appreciate it. Okay, is this? Yeah, I think this is good. Yeah. Okay, let's just remove it. Yeah. Okay, so we have some numbers. Let me close this. And is the OBS working? Yeah. Okay, so we have this. Now let's see, when will a number not be good? So if we don't want 101 as a subsequence, right? So if we have 10, then all of these should be zeros. If we have 0 1 0, either we can have all ones, or the number should be in this form 1 1 1 1, and then it should be then once we encounter 0, all of these numbers should be zeros. Otherwise we will never be able to get a good number. So this is the only format of the of a good subsequence. Now let's see, suppose we have 9 only. Let's take 9. So we have 1 0 0 1, and basically we want to transform this to 1. Either we can transform it to we can't actually transform this to 100. So we want to actually transform this to 1100. That is the closest good number that we can make, right? So we want to choose an integer greater than or equals to x and add 2 to the power x to n. Okay, the cost of this operation is, okay, let's see. So if we have 1001, first of all, let's get rid of this. So what I can do is I can add 1 to this, right? So basically 2 to the power, so what I can do is add 0 to this, so it will become, so when I am adding 1, so it will become 1 0 1 0. Now I can add 1 0 to this, which is equals to 2. This is equals to 1. When I do this, it will become 1. Yeah. So first I'm adding 1, then I'm adding 2, basically. Okay, so I think this is an easy problem. Minimum cost needed to transform x into a good number. So let's first see 6. Okay, so if we have 6, so 6 is like 110, right? 4 plus 2 is 6, so it is already good. So once we encounter a 0, encounter a 1, we are never encountering a 0 again. So it is already good. For 10, let's say 10, so 10 is I think 8 plus 2, right? So 8 plus 2, so we have this. Now what we can do is we can add 2 to this number to make it 1100. Then it becomes good. So that's that. Now, so we have 2 as the that. If we have 4 3, let's actually see the binary representation of this number. Okay, so we have this as the binary representation. let's see, 1010. Can I just copy this and paste it there? Is there a text button? I'm not very familiar with this. Now, where is the text? Yeah. Okay, so we have this now. What can we do? So first of all, like we have this zero, this zero, these three zeros, and this three zero, then this zero. First of all, what I can do is I can add a one. So this will become one, two, like 10, 10, 10, right? So it becomes 1, 1, 0. Okay, so we got two ones. Then I can add this here again, obviously. First of all, I need to check like if this is a bad number or not. Otherwise, I will not add it. I think I get it now. Like first of all, I should check that if it is exactly some 2 to the power, if it has all zeros or all ones, then I don't even need to do it. Uh, so my answer will be, let's say we have these numbers and the expected output is this. So first of all, how do we check that if this number is a good number or not? So what we can do is, okay, first of all, I want to skip the start zeros, and once we encounter a 1, then we want to check if we are getting another 0 or not. So these numbers are till 10 to the power 9 or 18. It is 12. Okay, it is till 10 to the power 9. So let's say int k. Let's make a good function to check if this number is a good or not. So if we have bool good, int of n, let's say int count is equals to 0. First of all, I want to skip the what should I say, like int k is equals to 0, while 1 less than k, n and 1 less than k. Actually, let's use a not. So while it is 0, then I will do k plus plus. Okay, so now I only have ones. So now I can go for while n and 1 less than k. What am I doing? So I skipped all the start ones, and now I should traverse like for k in range. Uh, or not, I don't need to do this. Redefine it and let's go till 30. If n and continue, uh, else I will say count plus plus. If my count is greater than, and now let's actually do this again, but this time what I will do is like obviously I encountered a 0. This time cout 0 handle and return. Otherwise I will say cout, let's say for now -1, and what are we getting? So we are getting this, I was not defined, so this should be k, and this also should be k. Okay, so we are getting -1, which is not good. Let's actually try to debug this code. Okay, so we are getting count of 2 in everywhere, and why is that? Okay, so first of all, I skipped all the case values. Now my till my k is less than equals to 30, I said okay, if that bit is set, then continue. Once it is 0, let's increment the count value. So what is my count value here for n equals to 6? Let's actually debug my n value also. Okay, so first of all my count was 1, and then okay, now for 10 we had a 1010. Okay, so why are we getting, why is 10 not a good number? If we have 1010, then first of all I want to skip this. Then once I encounter a 1, then I know like till this number is done. Like uh, okay, what we can do is I know what we can do. Okay, let's say int size is equals to 1, while sz less than n, sz is equals to 2 times sz. So we have this. Now what do? We return like okay, let's say int count is equals to int k is equals to 0. So this is actually not the correct way to do this, but let's debug my k value. What am I even getting? So no return statement. Okay, it hanged. Okay, my computer hanged. I don't know what to do now. I don't know what to do. Let's actually restart this now. Okay, so let's say we have this, and the return is true. Yeah. So first of all, my k was 3. So we have 2 to the power 3 equals to n. So let's say for I in range k, first of all, I want to skip the values where I I mean, let's say while int I equals to 0, while I less than k, and n and 1 less than I equals 0, then I want to say I plus plus, then debug I. So first of all I had a 3, then I said okay, okay, hmm. Let's actually try to debug this whole thing. So first we had a 0, then we had a 1 for n equals to, when it was an odd number we had a 1. Yeah, so when we have an even number I want to skip these values. Okay, so now we are getting some correct answer. Let's say for entire range, let's remove this and let's say I less than 31. Now I want to check, like I should go till k, and now I want to say that okay, now I should not get ones. Once I have got the ones, then I will never, should never not get ones. So now we have if n and 1 less than I, then continue. Else, okay, till this point it is, I think, correct. Let's say debug n and debug I, not debug I, debug k and debug I. So for n equal to 6, we had I equals to 1, obviously. Then we went to the next, so it was good. Then we had n equals to 10, so k was equals to 4. I was equals to 1, then for I equals to 2 we got a wrong answer and then return false. Okay, yeah, I think this function is now working. The good function is correct, so we have this as the good function. So this is actually just checking if the number was already good or not. Yeah, now what can we do? If we have a good number, then we should actually travel, and so if it was a good number we returned a 0. But now whenever I encounter, so we will have some zeros and then we will get some ones. So whenever you encounter a 1, what we will basically do is, let's actually say for I in range 30, let's say int answer equals to 0. Okay, so whenever we encounter a 1, we will basically uh, where is that, what was the penalty? Choose an integer and add 2 to the power x to n, and the cost of this operation is 2 to the power. Okay, so now whenever we encounter a 1, we know that it was not a good choice, but if n and 1 less than I, so if it was odd, then I will say answer plus equals to I, n plus equals to 1 less than I, and now if good n, then break, and let's print answer. Is this what they wanted? So first of all we get a 0, then we get a 1. Why are we getting a 1? Let's go till 30 and let's debug n. What does my n actually become? So first of all, now it becomes 12. So is 1100. So I wanted to convert my 10 from 1010 to this number 1100, which is equals to 12. So this is correct for 12. I think we are getting correct answer. No, we are not getting correct answer. Answer plus so what was the penalty? Achha, the cost is also 2 to the power x. So the answer plus equals to 1 less than I. Okay, so this is correct. But now we have this 432 My n becomes such a large number. And this is obviously not a good number, so why are we even getting this? Okay. If n, and if it was not a good number and we got this, then I should first of all I will add this to my answer. Then I will change my n and I will add it to the this, and now if what happened? Like debug n, let's debug the n values. So from 4343, can I print binary? Is there a STL binary function to print the binary of this number in case? So it is actually going to take me a lot of moves, so that is not the issue here. I think I should use long long and that will be it. So if we have, even if we have 2 to the power 30, let's actually go till 2 to the power 60. So this doesn't actually matter. Let's actually go till 60. And we went out of bound, which is not correct. Okay. Let's make this long long. Let's also make this long long and long long. Yeah. Okay, we are getting a correct answer now. I think let's remove the debug lines, and where am I debugging it? Because printing also takes time, so I don't want to waste any time in debugging it. So let's try to submit this, and it is in C++. Submit. Yeah, we got a correct answer. Let's move on to the next problem. Where are we getting an error? Is my internet connection fine? Okay, so we have 1 hour left. What? No one has actually solved these problems. And my rank is so bad, I don't know why. I wasted quite a lot of time in this easy problem array in the grid. Let's check the division 1 for this. So in the division 1 we have matrix modulo 35 submissions for this. So I think this is quite a hard problem. Why is it saying that I am offline? Is the stream working? I think it is working. So we have 35 submissions for this matrix modulo. Let's move on to the B problem. But why has no one actually solved this problem till now? This is concerning. We have an n cross n matrix B is called K strength. If it satisfies the following condition, each matrix from 1 to n square appears exactly once in B. If any element of B is reduced to K, the resulting matrix is symmetric. Formally, this means, for example, this matrix is both one strange and two strange matrix, but not a three strange matrix. Each integer appears exactly once in B if every element in B is reduced uh, reduced modulo K, the resulting matrix is symmetric. Okay, formally, that means 1 Bij mod K is equal to Bji. Yeah. mod k for every integer where x mod j denotes the remainder obtained when dividing. That is correct. Huh. But not 3 strings. Meanwhile, so what does it want? If mn is the largest integer for which there is mn strange n cross n matrix, Sahil has with him an n cross n matrix A, but some of its elements are missing. Each element of A is either an integer denote or a zero denoting a missing element. Okay, find the number of ways to fill in the zeros with integers so that results in the matrix mn strange. The numbers can be large, so printed modulo 10 to the power 9 plus 7. Okay, so it is a combinatorics problem. Is the stream working? I think the stream is still working, so yeah, the stream is still working. This is a hard problem. I mean, how can we go about this? Like, if we have, there are 48 ways to fill this up. Uh, I don't know even if I should try this or not. It will be just a waste of time if I mean, if it was an easy problem, then there should be at least 100 submissions on it right now. If it was a doable problem, right? But I don't think it is doable right now. And why is my score not increasing? That is even more concerning. And there is only one submission. What is happening in Dev 4? So even there are no submissions right now. Okay, what about Dev 3? Okay, there also we have 0 submissions. And in the Dev 1, we have only 38 submissions. So this is a hard problem. And okay, I think there is a subtask in this. Let's see. No, there are no subtasks. And there are only 32 submissions made. Let's actually try to see if I feel I will not be able to do it, then I will stop. We have an hour to spend, so why not? Okay. Sorry about that. Okay, the first line contains an integer t, then for each test case it contains a single integer and the dimension of the matrix. Next n line describes the matrix. Okay, so for 1 I will only be able to make 1. I mean, even if we have 0, we can only put 1 there. For 2, if I have okay, so for 2 we have 1, 2 and 0, 0, right? N equal to 2, it can be shown that m2 equals to 3 with the matrix this and no and there's no way to fill. So okay, so we want to first maximize it. Okay, and we want to do this in big O of n square time. What? Yeah, let's try to observe some things, like if we have n equals to 2, like for n equals to 2, what are the metrics that I can create? I can create 1, 2, 3, 4, and I can rotate these, right? Right. I can create 3, 4, 2, 1. Maybe I should I should just take the uh, that I should first only take the symmetric part. So I will take 2, 1, 4, 3. Then I can make uh, let's take let's say I will fix the 1 as here only, 1, 4, 3, 2. I mean, there are several ways. What is 1 mod 3? 1 mod 3 is I mean, there is no point taking k greater than n square, first of all. Now, because the matrix will be same, so it will be never symmetric. If I want this to be symmetric, for n equal to, it can be shown that m2 equals to 3. For example, with the matrix, there are no ways to align with 3 strange though. So the answer is 0. 3, 4, 1, 2. So if we have 3, 4, 1, 2, if I take modulus with 3, this will become 0, 1, 1, and 2. So this is not symmetric. I mean, is the transpose equals? So if I take transpose of this, so it becomes 0, 1. Okay, it is symmetric. Sorry about that. So it is symmetric because these values are equal. Okay. So the problem was, let mn be the largest integer for which the mn strange n across n matrix exist. So first the problem is to find out this thing. Like if I take modulo, then what will be the largest matrix that exists? This is tough. This is tough. Can I write a brute force for this? Can I even write a brute force? Like if I want to take the transpose of a matrix, then and consider all the possibilities, even if I do that. Okay, there is only one submission for this. I'm not sure how to go about this. Hmm. I'm really not sure how to go about this, but we have 56 minutes remaining. Should I waste my time? Should I waste my whole 56 minutes on this problem? Or should I just move on to the next problem? Maybe I should. No, I don't think that will work. Okay, what we have is basically, if we have numbers like 1, 2, 3 till n square, if I take modulus with k, then I should have at least all the numbers should. No, 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 no. Uh, let's say you have numbers like 1, 2, 3, 4, 5, 6, 7. Okay, let's try for 3 cross 3 only. Um, let's try for 3 cross 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. And what I want is I want to have one. I mean, I don't care about these numbers. I want to have aij equals to aji. So basically, I want to have at least 1, 2, 3. So I want to have at least 6 numbers, 6 distinct. So basically, n square minus n numbers should be uh, so if I have n square minus n upon 2, numbers should be same. Basically, they should be in pairs. So what we should have is just the upper triangular matrix after when I take the mod. Okay. So if I take the mod with actually what I should do is let's actually do a brute force for this. Let's say for n is equals to 3, I want to have L is equals to, for I in range 1 to n into n plus 1. Okay. And now I want to take modulus. Let's say for k in range let's make this a is equals to L dot copy, but like why not? Okay. Now I want to traverse in this L. So for I in L in A, add I mod k. So in the end, if len s is how much? Like if my len s is at least like is at least less than equals to this upper triangular matrix, and this upper triangular matrix is basically if I have 1 2 3 1 2 3 9 upon, I mean, we want to have n plus n minus 1 till n. So 1 to n, right? 1 2 3. So n into n plus 1 upon 2. So the size of this should be 3 into 4 upon 2, which is equals to 6. So I don't actually care about these numbers. I want to have, I want to remove these. So 1 2 3 4 5 6. So n into n plus 1 upon 2. So let's actually calculate that. Num is equals to n into n plus 1 upon 2. If it is less than equals to num, print k. Let's run this. So the maximum for n equal to 3 is 6. Let's try for n equals to 2. For n equals to 2, we are not getting anything. Why? Um, let's say we have 1, 2, 3, and 4. So we want to have 1. These two can be anything, like obviously. If I take modulus with 1, then it will be 0, 0, 0, 0. If I take modulus with 2, then it will be 1, 0, 1, 0. I can do that. If I take modulus with 3, I will get 1, 2, 0, and 1. So I distinct, I have only 3 numbers. So 1, 2, 3. So 1 plus 2 is equals to 2 into 3 upon 2 is equals to 3. So why are we not getting it? Okay, so we have 3. Okay. Okay, so the answer for this is 3. Now let's actually do this for all the numbers for n in range 1. Let's actually take from 2 to let's say 10, and now do something like this. If we have this, let's also keep the max value. So max value is 0. and let's say max equals to k, and print I comma n comma k, n comma mx actually, n comma, so for 2 it is 3, for 3 it is 6. So if we have this number like 3, 6, 10, 15, 21, so if we have something, a series like 3, 6, 10, 15 and 21 and so on, let's actually search for this series, what this series is looks like. So for that we have an encyclopedia of numbers. So I think it was OEI, one line encyclopedia. So let's actually search for this 3, 6, 10. So we have 3, 6, 10, 15, 21, 28, 36 and 45, and see if we can get something meaningful. Triangular numbers, so these are called triangular numbers, and we have, okay, so for an we get the maximum mod as n into n plus 1 upon 2. What? Binomial of n plus 1 upon 2, which is equals to n into n plus 1 upon 2. So for 2 we get a for 0, for 2 we will get a, okay, so at least we got some information that these numbers are called triangular numbers. Okay, let's go to Wikipedia and search for it. So this is equals to n into which is n plus 1 c2. So basically it is n plus 1 in n into n plus 1 upon 2, that is correct. So it looks like, so how are these triangular numbers? So do we get like 2 into 3 upon 2, 2 into 3 upon 2 is equals to 3, for 3 into 4 upon 2 which is equals to 6, which is correct. Yeah, I think okay, at least we know the answer. Like my k value, like my maximum value is going to be equal to k. So if I have int n, let's start taking the input. I think we can solve this. So if we have n and k, if we have n cross n matrix, and what was the input format? First we have int n line and the dimension of the matrix, and the ith line contains n space separated matrix. So let's say int n, c in n, then I want to have a vector of vector ints matrix of n, then vector int of n comma, actually I don't care, so let's say for I, for j, c in matrix of I comma j. Okay, so we have this matrix. Now what we can do, uh, I want to traverse in the matrix, and like I know that what was my k value, right? So what is the required output format? Okay, let's try to find the answer for this test case. Like I know my answer should be 6, right? So for uh, let's tinker this code a bit. Let's say my n is equals to 6 only. No, n is equals to 3 only. So we are getting 6, and now I want to print my this value also. So let's say for k in range 6 comma 7, and now I have this, and I also want to print this s value. How do I print it? Print s. So we are getting numbers like 0, 1, 2, 3. Okay, let's actually do this. We have, how do I add a new page in this? Can I add a new page? Okay, let's actually clear it. Okay. So if we have numbers from 1 to 9, so if we have numbers from 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay. Now if I take modulus with 6, so these numbers will remain same, 1, 2, 3, 4, 5, and now this is going to become 0, 1, 2 and 3, right? So my matrix, like how many matrix can I make? If I have 1, 2, 3, let's just count the number of matrix that I can make from like if I have all zeros, then let's actually try to make one of the matrices. So clearly 1 is repeating, 2 is repeating and 3 is repeating. Okay, so and these are like non-repeating numbers. So 4, 5 and 6 should occupy these spaces, right? And then 1, 2 and 3 should occupy these spaces. So the number of ways to do this is, for here we get a n factorial, right? And for here we will get the repeating digits. So these are actually equal to like for this case it will be equal to 3 factorial. Now since I have set this one, so this will become 1, but now we have a choice to make for these two. So we have 2 into 1, which is 2 factorial. So what is 3 factorial? 3 into 2 into 2. So 3 to the 6, 6 into 2 is 12. So the answer should be 12, not 48. Am I missing something? Am I missing something? They should have explained it for 3 also. I think that is why so less people have actually solved this problem. Okay, 4 people have solved it. Actually 5. I think it will increase. Let's keep doing it. Okay. So for n equals to 3, we will have k equals to 6. From 0, 1, 2, 3. Okay. So if I have one of these elements, these which are non-repeating, so these non-repeating elements constitute of 0, sorry, they constitute of 4, 5 and 0, right? So they constitute of 4, 5 and 0. So if these elements occur at the diagonal elements, then we are toast, the answer is simply 0. Okay. Otherwise, if there is some element, then it has occupied this space. Somehow 1 is linked to k plus 1. Okay. 2 is linked to k plus 2 and like that. So so if we have a 1 here, I have pretty much fixed that this number should be 6 plus should be 7, right? I have fixed my 7 here. Now here I can place these numbers like 4, 5 and 6 in any order. So the number of ways to fill these is 6 factorial, sorry 3 factorial, because I can write them in any order I want. So there are 3 factorial ways, so 3 2s are 6. And the number of ways to fill these like 1, 2, 3, 4 is 4. No. Here I get a 2 factorial from here, then 2 factorial from here, and 2 factorial from here. So I will get 2 factorial times to the power of 1, 2 to the power of 3. So this is 6 into 2 into 2 into 2. So 6 2s are 12, 12 2s are 24. Okay, so that is why we are getting 48. At least we cracked how we are getting this. Now what we can do is I think I get why this is happening. So let's say int k, the answer will be equals to n into n plus 1 upon 2 that we just proved. Okay. So we have this now. I want to first I want to make a set. Sorry about that. First I want to make a set and find like what are my repeating characters. So actually even before taking the input I should do this. Like once I have this k value, I want to check like okay, I want to check like if the diagonal element is not something that is, how should I do this? Okay, let's first take the input and now let's actually do this whole loop again just to check if it is if the answer can be 0. Because if the answer is 0 then there is no point in doing all the mathematics stuff, right? So what we can do is first of all I will traverse in the diagonal element. So if my I equals j, then I have to check that when I take mod, like if I take mod, so if uh, matrix ij mod k, if matrix ij equals is greater than k, then I will simply return re then I will simply see out 0 and return, right? Else I will see out -1 for now because there is no point in doing that. Okay, we are getting a lot of -1s now. Okay, why is this happening? Like for n equals to 2, my k value was 3. So if we had 1 and 2, so why are we getting this? So if we have 1, 2, 0, 0, for 2, k is equals to 3, right? So if I had 1, 2, 3, 4, so this is 0. So 1, 2, 0 and 1. So these are paired. 1 and 4 are paired. So 1 and 4 can't come at the diagonal elements. The diagonal elements can only be 2 and 3, right? So if I have 1, okay. So how many diagonal elements will actually there be? If I have like 1, 2, 3, 4, 5, 6, 7, 8. What is my value of k? K equals to how much? 4 into 5 upon 2, which equals to 10. So if I'm taking what, 10? Yeah, it is 10. So we have numbers till 16, right? 8, 9, 10, 11. So this will become 0. And now this becomes 1, 13, 14, 15, 16. So this becomes till 6. So we have numbers from 7 to 9. So these are the only diagonal. So we only have 4 diagonal elements. So from k minus 1, k minus 1, k minus 2, k minus 3, k minus 4. So these are the only diagonal elements that I will have. So what I can do is I have to check that if this is possible or not. So for that I will make an unordered set. Let's say I think I will do this in Python maybe because the code will be much shorter. I think I will do it in Python because the code will be shorter. Let's actually do this in Python. So int input, uh, but the runtime will be slower. So I don't know what should I do. Let's actually make an unordered set. Okay, unordered set of integer s, and for I in range n. So from 1 to n, I will say s dot insert what, k minus I. So k minus 1, k minus 2 till this. And now once I have this, I will have to check for something. If this is this, and if matrix ij, so I have to find this matrix of this. So if the s dot find matrix ij not equals to s dot end, then I will have to print a 0. Yeah. So for 1, okay, 1 was a special case, 1 cross 1, if n equals 1, then we don't need to do anything. So that will be handled separately, but okay. What is the expected output for this? Like 1 into 2 upon 1 is 1, and 1 minus 1 is 0. So okay, doesn't actually matter, but at least we are getting 0 for this. That okay, at least we are getting a 0 for this test case. But now if one of the, let's say, okay, let's say we defined it. Now now what? First I want to get the answer for the answer for the diagonal elements. So I will have to traverse in my diagonal elements. So I will say for I, for j, so traverse diagonally. And actually I can remove this loop. I don't even need this loop. So I will say matrix I, okay. Yeah. Now I will traverse in the diagonal elements, and first I have to count how many. Now I will say, like, okay, I will have to count how many diagonal elements are actually there, which are uh, I don't know how to say this, which are fixed already. So if my, let's say, int count, count equals to 0, if matrix of I comma I is not equals to 0, then I will say count plus plus. So I'm counting the diagonal elements first, and the answer will be simply n factorial, right? So for that I can say int answer equals to 1, and now my answer will be n factorial. What I can say is answer is equals to, okay, let's first say count plus plus, obviously, and answer equals to answer times count mod mod. So now I've calculated n factorial in big O of n time, and now I need to calculate the swaps that I need. So if I have something like uh, how do we traverse this matrix? If I have a matrix n cross m, so I want to traverse it, like I don't want to go to the diagonal elements now. So if I have something here, I also want to check the element at here. So if I have ij and this is ji, so what are the pairs of ij that I can get? I think it is, I can do it in big O of n square. So this will become, no, I've only analyzed for n equals to 3. I should also analyze for n equals to 4, right? So if I have n equals to 4, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16. So if I take mod with 10, this will become 0. So actually I can take this as the take k with me. So the unordered map code is wrong. Uh, let's actually go from 0, because after that it becomes 1, right? So I have to go till less than n, not till n. So that was wrong. Now we are getting minus ones and all in all the situations. Why is that? 1 should not be the case. If I have, why getting this? Like for is 0, so 3 can come in the diagonal element, I think. Yeah, 3 is a diagonal element, 2 is a diagonal element, but 1 is not a diagonal element. 1 and 4 are non-diagonal elements, so 1 should not come in the diagonal element, basically. So if my 1 is not in the diagonal element, let's actually debug this S value. Okay, so 2 and 3 are the diagonal elements. And now I said that, okay, if I and I is not is equals to S dot end, then I should say minus 0. Yeah. And now everything is a 0. Wow. So why is that? Okay, because I did not insert that. So S dot insert 0 also. Okay, so at least we are getting 0 for this one. Yeah. Okay, now we want to have this, and let's debug my answer. What do we have here? At least my answer is 1 right now. So let's actually print it. Answer. Right. So we have right now my answer is 1. So for n equals to 1 case it is correct. Now I want to traverse in this matrix, like obviously, and I don't want to traverse in my what should I say? Like I don't want to traverse in. Okay, so I will have n square minus n pairs. So I'm going to have n square minus n pairs. So I will have to divide it by 2, and basically, so I want to have I will have n square minus n pairs. So I want to traverse in this whole matrix. If I equals j, then I will say continue. Okay. So if I equals j, I will continue. Now I want to calculate the number of pairs that I will get. So let's say int count equals to 0 again, and if matrix I and j not equals to 0, so if it was not equals to 0, then now what I can do is I can clear this S and I should insert all the remaining numbers in it. So let's say a new S matrix. So set int S2, and for I in range 1 to n square, actually no, I should do it here only. Like okay, obviously I am doing it here, k minus I. So I should be able to do this, like if k minus n minus 1, for I in range k minus n minus 1, and then for I in range that, I should be able to insert it. So I can say let's say S2, let's also make another set S2, right? And then I can move from for I in range 1 to less than equals to that number, that is uh, okay, let's go to n square only. Okay, if n, if s dot find I equals s dot end, then I will insert it in s2, right? So if we have this, and then I can say s2 dot insert 0, let's say debug s2, what are we getting? So my, for the third test case, my s2 is this 1 2 3 7 8 9. Yeah. Okay, so we have this. Now what we can do, if my matrix ij is not equals to 0, then uh, my pairs will decrease by 1. But now I have to check, like if uh, s dot find not s2 dot find matrix ij not equals to s2 dot end, Then I will say, okay, let's say count plus plus. So I will increase my count, and then I will remove both the occurrence of those numbers. So s2 dot erase matrix I and j, s2 dot erase matrix I and j plus k mod k. So if it was the smaller number also, what if we encounter a smaller number? What if we encounter a bigger number? So if we were to encounter a big number, then okay, let's first check if we have if this is if this is a smaller number or bigger number. So if matrix I and j mod k equals matrix I and j, so that means it was a smaller number. And if this is a smaller number, I should I should remove uh, both the numbers. So s2 dot erase matrix I and j, and duplicate this line, plus k, right? Otherwise, else I should remove, if this was a bigger number, then I should remove uh, s2 mod j and minus k. I mean minus k, right? So now after this is done, like once I am done traversing, debug my count value. So my count value is also 1. The answer for 0 is pretty clear. Like, okay, if I have 1, my count is 1. That means how many pairs did I have? Initially, I had int pairs is equals to n times n minus n. So if I had these many pairs, debug pairs. Let's go for in this test case only, because others are just hindrances right now. Yeah. So we had 6 pairs, and actually I should divide this by 2. Minus count, right? So we had actually 2 pairs. What is my count? Count is 1. So we had actually 1, 2, 3 pairs, but now we have 2 pairs. And for every pair, I have 2 factorial possibilities, right? And then I can okay, so for every pair I have 2 possibilities, so I can say 2 factorial to the power the number of pairs that we have. So I have to multiply it with 2 to the power p. So 1 less than pairs. So debug answer times 1 less than pairs, and if I do that, what will I get? So the answer is 4, which is wrong. Let's actually remove this count. 8 6 are 48, yeah, but I should not remove this count, because I will have the minus count, and now I am also able to multiply this by pair factorial. So I should also calculate the factorial of this pairs. So what can I do? Like, okay, this is correct. Let's say, where is the answer variable? It was the answer should have been calculated in this case. What was my answer here? Okay, so the answer was initially 6. Okay. Okay, the answer was initially 6, and then I got a pair value of 2. Okay, the answer was initially 6. Then now I want, first of all, I can't go in this order. So first I have to calculate the factorial. Now factorial can go till n square, and if I have 500, 500 times 500 is 2 into 10 to the power 5. So let's say int n, uh, int let's say const int capital N is equals to 2 1 2 3 4 5 plus 1. Okay, let's say int n, int factorial of this number is n, and inverse factorial of n plus 1. Actually, let's go till n plus 1, and then I have to calculate for all these numbers. So let's go for I in range 1 to 1 to capital N, and let's say factorial of 0 is equals to 1, and inverse factorial of 0 is equals to, I will need my mod inverse template. So let's say mod inverse, and now I will say factorial of 1 is equals to mod inverse of 1. What is the modulus value that I need? Modulus value I need is, I think we can do this. I think I'm getting close. Okay, so it will be equals to factorial I is equals to factorial I minus 1 times I, and then inverse factorial of I is equals to mod inverse of factorial I, and I should take modulus here, right? So this is the factorial. I have calculated all the factorials, so my answer will be equals to answer times, I will need 2 to the power of pairs, so I will also need binary exponentiation here. I think I forgot to import the template, so let's just copy it from Geeks for Geeks, or this, because it is just a template. Let's actually make this int 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 and let's also take the modulus values. It might give, otherwise it might give me a wrong answer. And then I think there is a power function also in C++. So for that I can say answer is equals to, first of all, power, power of what? Power of 2 to the power of pairs, and the value is mod, and answer is equals to, and also let's take modulus here, mod. Now answer is equals to answer times factorial of I, factorial of pairs, and take mod. And now I want to have print the answer. No matching provider int long long int long long. Achha, okay, so I can't actually give modulus here. Can't I use modulus? Okay, so I don't think I can use this here. Okay, let's actually go to my VS Code. I think I forgot to import the template in this Sublime. What am I doing? Actually, I recently shifted from Sublime to VS Code, and so I forgot to import some other templates. It is not that I don't remember the code, but I don't want to make any mistakes right now. And the VS Code is pretty slow, and that is why I shifted from VS Code to Sublime. So I should now have binary exponentiation code here, and now I can say this. Okay, so we are getting correct answer now. Let's actually remove all the debug statements. So this debug answer and debug here. Okay. Okay, so this is correct. Let's actually see if it was working for the other test case also. Okay, so this is correct. Let's actually submit this. And we are getting wrong answers. Okay, I calculated all the factorial values and the inverse factorial values, but I think did I divide it wrong? This is correct. Like I'm reducing the number of counts, and then I have a lot of possibilities. Like, okay, binary exponentiation 2 to the power the pairs, that is the number of pairs, and then I can switch them. So factorial of pairs times mod. I don't know why this will give me a wrong answer. Let's actually see if I make this 2, then what will be the answer? So the answer reduces to 12. Really, like we have 3 factorial, so 6 times, now I fix this, so 2. So we only have one pair, 6 into 2, which is 12, so this is correct. And if I say, like, if I say 1, 2, 3 here, the answer is only 6. If I say 1, 2, 3, 4 as one of the this, the answer is 2. Yeah, because there are only two possibilities, because so I think this code is correct. Why am I getting wrong answer? Okay, so I don't think I will be able to solve it in 29 minutes, or maybe I'm at least it was not giving me any TLE, so why are we getting a wrong answer? Hmm. How many people actually submitted it? So we have 32 submissions on this. Okay, 800 submissions and with an accuracy of 4.1. I think this is a stupid problem right now. Okay, I don't think I can solve this in 12 minutes, so sorry about that if you are here for this problem. But what I can do is now I think I have 12 minutes, so what I can do is I will add the time codes and I will make this stream public in 12 minutes, and then we will discuss the solution of these live. Okay, so if I have I don't know what to do. Let's actually make the, can I add the time codes? I am not familiar with YouTube. This, can I get the current timestamp that I am at? Okay, this was the intro, and now I mean, I think this is a really bad problem because only 38 people have solved it, and the difficulty should not be this abrupt. It should be linear. And this is a doable problem. I think I am very close to this. Factorials. The number of pairs can not go till n square, so that is okay. I have n plus 1 here. Go to n factorial. I don't think I'm using this, so let's actually comment it out. Uh, what we are actually missing, am I using the divide operator somewhere? So what we can do times, okay, let's actually use that. Okay, so we have this. What I can do is, first of all, I will say that, okay, I am taking the modulus. Now, when I'm trying to divide it here, I should, like, when I do n into n, n into n minus 1, n into n minus n, or I can say n into n minus 1, that is the same thing. Okay, let's actually do it like this. Int pairs is equals to n into n. Let's take modulus minus n, and let's again take modulus. And now I want to say inverse, not inverse factorial, I want to say mod inverse of 2, and then again take modulus and say minus count, and then here I want to take modulus again. Maybe that is why I was getting a wrong answer. And now we are getting something very wrong. So why are we getting this? Is my modular value correct? So it is 10 to the power 9 plus 7, and here it was 42 people have actually solved this problem. We have 10 to the power 9 plus 7. Yeah. Okay, let me just change the name of the stream to, let's say, div 2 A, B, and C. I'm not sure why am I even getting this as a wrong answer. I think I did everything correctly. Okay, let's convert this to 0, 0, and 0. Okay, now we are getting 48. Let's try to submit this again, maybe. Okay, still we are getting a wrong answer. Hmm. And I removed the required number of pairs. Then I said, okay, 2 to the power. So the number of factorials. Then the factorial between them was 2 factorial only. Because we had 2. What if we had for n equals to 4? Let's actually do it for by hand for n equals to 4. Maybe we will get something. So let me clear the page first. Okay. Okay, so for n equals to 4, we have 1, 2, 3, 4. So first of all, I will have 4 factorial for the diagonal elements. Then I add 1. So the 1, 2, 3, 4, 5, 6. So we have 2 factorial to the power of 6 times 6 factorial times 4 factorial. These are the number of matrices that I will get. Okay. So that is what I am calculating. If I have any number here, if I have any number, then I will have to remove that. Like that is only giving me one possibility. So it will go from here, and then this will become 5 factorial. So the number of pairs was 4 into 4, 16 minus 4 upon 2, that was the number of pairs. So did I actually forgot to, no, I did upon 2 here. So that is correct. So 4 minus 4 is 12 upon to 6 pairs. So 1, 2, 3, 4, 5. So 6 is correct. Yeah. 4 factorial, that was the diagonal elements. So whenever I get a 0, I was getting a 0. So let's say if I have 4, 5, and 6. You get an 8, which is equals to the number of 2 into 2, 4 into 2, which is 8. So that is correct. But what if we had a 7 here? We get a 0, which is also correct. So it should be a combination of these numbers. Okay. What if we had completely everything as 0? Then what are we getting? So we are getting 288. I think 288 is wrong answer, because for 3 we have 3 factorial times the number was 1 2 3, so 2 factorial to the power of 3 into 3 factorial. So 3 factorial is 6. 6 into 6 into 2 to the power 3, 8. 48 into 6. What is 48 times 6? No, it is correct. So 288 is correct. Let's see for n equals to 4. What if we had all zeros? It's such a big number. So 105920. Is it equals to this? So we have 4 factorial times 2 factorial to the power of 6 into 6 factorial. So what is 6 factorial times 4 factorial? 6 factorial times 4 factorial times 2 to the power 5 is 3264. It is 115920. No, this is not correct. 4 factorial times 6 factorial times 2 to the power 6. 2 to the power 6 is 3264. So 11590. And when we take modulus, if I take modulus with 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 7, 1105,920. So 11, okay, so that is correct. I don't know for which test case am I getting wrong, and there are only 2 minutes remaining. So I don't think I will be able to solve this problem. 60 people have actually solved it. I think I'm close, but I'm not sure. Okay, I think I will just make this playlist live, and let's discuss each of these problems one by one in this live stream only, because I will not get time to discuss these problems again and again. Okay. So let's close them and let's discuss each of these problems one by one. What I can do to just to get some, can I copy this? So can I share this link? Yeah. So what I'm going to do is, first of all, okay. So first of all, we have this man of the match. I think it is an easy problem. You can just calculate the scores for each player and just print the score that had the maximum number of points like this. So that is the code. And if you, so I think I will just say make an explanation video here. Right. Okay. Let's say Arya in the grid. Okay, so let's also discuss this problem. I will just show you how I solved it. So basically, when you are trying to solve such problem, what I realized was, let's say you are in 3 cross 3 grid. Okay, So 1, 2, 3. And if you are starting from here, and let's say you have L equals to 2. So from here you can traverse these, and then you can traverse this. So there are only four, right? So uh, so if I'm starting from here, so I can go till 3 only, right? So I can have 1, 3, and in the downward motion also I can have 1 and 3. So there are only two numbers that I can go to in x direction, two numbers I can go to in y direction. So the answer is simply the product of these. So let's say if you are at n, so if you have number line like 1 to n, and you are somewhere at x, and the length is n. So what you can do is you can go in the reverse order and get the first element that you can be at. So let's say it is the start of the x, and then you can go like this in n length till you can reach the last element. So let this be s fx, so the finish line of x. Okay, and from the summation of arithmetic progression we know that fx is equals to sx plus n minus 1 times l, right? So from this I will get the number of terms in this as fx minus sx upon n upon l. I can't rub this. Yeah. So from this I will get the number of terms as upon l plus 1. So these are the number of terms I will get in x-axis. Similarly, you can do it for y-axis, and when you multiply these two, a into b, you will get the number of values like that. So if you see the submission, what I did was I first calculated the value for a, so that is fx minus sx upon l plus 1, and then I calculated the value for b, and that is it. Let's see live video here. Let's actually make this public, otherwise people won't be able to access it. So yeah. Okay, and let's see the third problem, which is transformation cost. Okay, Arya, Ayush being in IIT, then yeah. Okay, so for this problem, what I did was, let's say you are at some, let's say you are given some numbers. So for this problem, what we have is the transformation cost, right? So if we have 4, and let's say for 4, a good number will have ones at the start, right? Some number of ones, and then it will have all zeros. So this is what the number will look like when it is at the start. Let me just do that in my submission, so people can actually come here right now and ask questions if they have any. So I can say live solving video here, just if someone wants to actually see it. Yeah. So for this problem, let's say you want to make the number like this. So let's say for n equals to 9, 9 is something like 1001. So it is not a good number because it is not in this format. So if I add 1 here in binary, I'm doing this binary additions, right? So if I make this like this, if I add 1, then it will become 1010. Now I should add 10 to this. So this will become 1100. Now it is in this format. Now it is in this format. So it is a good number now, right? So that is how I'm converting any number to a good number. Let's say you have something like 101100110001. Let's say you have something like this. So first you are going to add 1, then this will become 10. So you will have to add 10 again. So this will become 100, and you will keep doing this. Then it will become 1 here, right? And now when you add 1, so this whole thing will become 1000. So it will become all zeros. Then you can add 1 this whole thing again. I will have to end the stream soon, otherwise my mother will scold me, right? Okay, so we have this now. After this will be, so in the end what we have to do is we want to make this equals to 11000. So we want to keep adding powers of 2 to make this whole number like this. So that was the idea behind this. Now if you see the code, I wrote a good function just to check if the number is good or not. And now I'm adding the powers of 2 whenever I encounter a 1 and check once the number is good, then I don't need to do anything. I will just break out of the loop and then I will print the answer that I had to do that. Now you can watch the previous how I solved it live to actually get the intuition. And I think I will just uh, end the stream here around. Okay, so thanks guys for watching if you are still here. So thanks, bye bye.